Today we're going to walk through how to boost network performance by using intrusion prevention and detection systems on a network. The objectives for today's lesson will be to compare IPS, Intrusion Prevention System, with IDS, Intrusion Detection System solutions. Highlight the benefits of IPS and IDS solutions, and view a demonstration on IPS configuration. So let's dive in. Do you remember the lesson challenge from our last lesson? As someone who is knowledgeable on segmentation policies, you were asked to recommend which segmentation policies a large finance company should implement on their network. From our lesson, we learned that there are many types of segmentation policies, but the two that would greatly reduce threats and improve the security on the company's network are segmentation with VLAN, so virtual local area network, and access control lists. The term IPS refers to an intrusion prevention system, and IDS refers to intrusion detection system. Both are applied on a network to help detect and prevent emerging threats on the system. On a sensitive system, where there is a need to have a high-level security alertness, an IPS is a definite plus. It monitors and captures possible malicious traffic on the network. Being able to receive real-time alerts of a threat on their network gives companies an edge on security. The network administrator can pre-configure the network in such a way that all the access ports are shut down. Do you remember the difference between an access port and a trunk port? In case you need a quick reminder, a trunk port refers to the connection between two switches or a router, while an access port refers to the connection between an end device and a switch. In our demo today, we'll be configuring security on both our access port and our trunk port to increase the level of protection on a network. But there's plenty to talk about before we get there. When talking IPS, the term IDS or Intrusion Detection System also pops up. We'll talk more about the differences between these two systems just now, but essentially, an IDS analyzes network traffic to detect cyber attacks, while an IPS analyzes packets and stops them being delivered if necessary. An intrusion prevention system, as the name suggests, is designed to prevent an unknown or malicious threat from entering a system. IP technology is used to inspect every bit of traffic and prevent potentially damaging traffic from being loaded or distributed on the network. Always keep in mind that threat actors are constantly trying to find new and smarter ways to break into a system, so it's important to stay ahead of them. An IPS often works hand in hand with a firewall on a system, providing complementary support. The intrusion prevention system is placed between every source and destination. The sources in this case are the points at which the traffic originates from. The destination is the point to which the traffic is sent to. So in most cases, the destination is configured with an IPS, which inspects and analyzes every bit of traffic, and then makes automated decisions based on the pre-configured rules or instructions. Some of the automated decisions include blocking traffic from unknown sources, analyzing traffic for malicious payloads, blocking packet relay, as in an API attack where a threat actor tries to resend a legitimate packet but includes malicious payloads with the packet, reducing false positives on the network, for example, when legitimate packets are misread as threats. And others are helping to detect existing malware, for example, Trojans, backdoors, and rootkits, and sending real-time alerts to administrators. So now that you can see how useful an IPS can be, you can see why it is always encouraged to include these types of security measures on a network. Why? because if you can detect a malware, chances are it could be mitigated. So what is an intrusion detection system? As mentioned earlier, an intrusion detection system, IDS, works hand in hand with the IPS to improve security on a network that requires high security standards. An IDS can be physical hardware or virtual in the form of a software-based IDS, which monitors a particular network based on its configuration. An IDS analyzes known and unknown traffic, looking for intrusions and symptoms. When a violation on the network is detected, it is flagged in real time. So now you can see why you would need both an IPS and an IDS. In upcoming lessons, you will see how all this data can be used in SIM, Security Information and Event Management, to help companies have better understanding of their network. An IDS uses two main mechanisms to detect threats on a system: signature-based detection and statistical anomaly detection. Let's look at each one a bit more closely. Similar to indicators of compromise we referred to in our previous lesson, an IDS uses known signature patterns to identify threats on a system. When a packet enters the network, it is inspected for any known signatures of threat. If no threat is found on the packet, it is sent through, but if there is a threat, it is flagged to the administrator in real time and block the traffic from going through into the network. When malicious traffic is captured and inspected, its signature is recorded on the system so that when the traffic re-enters the system already knows all about it and can flag it even quicker. Statistical anomaly detection occurs when the system is unaware of the threat. So when the traffic enters the system, the packet is inspected for any anomaly, such as payload or other features of a malicious threat. If the traffic in any way exhibits any malicious features, the system categorizes it as a threat by triggering a unique pattern to exploit the system. Did you know that one way to classify intrusion detection systems, so IDSs, is according to the response they take when security breaches are detected? They catch and respond to attacks either by using a signature recognition engine, anomaly recognition engine, or a honeypot, which is setting or baiting a trap for hackers. The IDS operation is based on a set of pre-configured rules, such as comparing traffic on the system with known and unknown IOC signatures, actively scanning the content of each packet once it enters the network, flagging every threat in real time and associating that threat with an IOC, and constantly monitoring traffic behavior to detect malicious activity. Monitoring changes to the system settings and configurations on the network, and flagging any unauthorized change that is detected to the administrator. When both IPS and IDS are active on a network, attacks like zero-day exploits can be mitigated, even though threat actors are always finding new ways to evade detection. IPS and IDS solutions work well together to increase the security of a network, but they do have differences based on the action taken when threats are found. Here is a table highlighting the main differences between them based on the level of protection they offer and how they operate. The prevention attribute with an IPS is used to prevent incoming and ongoing attacks. And with an IDS, it mainly detects ongoing attacks or threats, but does not have the ability to detect incoming threats. The attribute operations with an IPS, it uses a heuristic-based detection, a combination of AI and ML, to detect the running pattern of software and cross-check with real-time IOC from threat intelligence reports. And with an IDS, operations are used to monitor and detect changes on the system. The attribute automation with an IPS operates automatedly. If a threat is found, the administrator does not need to perform any action. And automation with IDS requires the attention of administrative operators to confirm and verify flagged results on the system. Did you know that with IPS and IDS, companies can use automated network software using ML/AL, machine learning and artificial intelligence on their system? This will help them to make more comprehensive security decisions based on the configuration set by the network administrator. IPS and IDS solutions can prevent and mitigate various threats on a network, including denial of service (DOS) attacks, distributed denial of service (DDoS) attacks, zero-day vulnerability exploits, worms, viruses, and Trojans, and many more. As you saw in previous lessons, Internet Protocol uses TCP or UDP. When an IPS wants to prevent a session or traffic, it terminates the TCP session that was created between the source and destination. Each time any traffic is detected or prevented, it is added to a block list to always prevent it from accessing the network in the future. You would have probably already seen why companies need both IPS and IDS solutions on their network to attain high security. But in case you need more convincing, here are some of the benefits of these two security solutions. Backdoor protection. IDS configurations typically identify backdoors based on known and unknown threat signatures. Automation. When combining IDS and IPS solutions, companies are able to make complex decisions based on pre-configured instructions. Compliance. Companies can use IDS or IPS solutions to help tick off compliance requirements and prevent a lot of issues that may arise if there was a breach. Policy enforcement. IDS or IPS solutions are configurable to help enforce internal security policies at network level. For example, if you only support only one VPN, you can use the IPS to block other VPN traffic. Did you know that several things must happen before an IPS or IDS can be implemented on a compromised network? For example, a security audit must be carried out, accessing the damage, repairs needed, and new countermeasures installed. The security policy should be updated to reflect this change. As mentioned earlier in the lesson, an IPS solution requires certain configurations to enable it to detect malicious traffic on a network. That is our next stop. Today's demo is all about configuring an IPS. We will be configuring the router to identify the syslog server to receive logging messages. We will also set it to display the correct time and date in syslog messages to monitor changes on the network. And will enable the IPS solution to produce an alert and drop every ICMP echo packet. For this demo, we will be going through some configuration for our IPS on our network. So, if you look at the topology we have, you actually see we have the same topology as we had for our ACL. But in this case, we removed all the configurations we used during our ACL configuration. And we are just left with the OSPF routing protocol. So for this demo, we have the objective, which is to enable iOS IPS configuration on our network. And we will define the configuration to capture a specific network protocol on the network. And lastly, we will be verifying the connection after the configuration of the IPS on our network. So the IPS is going to be enabled on the router in Dublin. And the IPS will be scanning all traffic coming into the Dublin network, while the IP is configured on the domain network. The IPS is going to be hosted on the server with the IP address of 192.168.5.4 after configuring all of this. So we will be testing out our IPS configuration. Then we will be blocking all the ICMP ping echo requests sent to our network. Remember, the ICMP is mostly used to verify connectivity between end devices. So, the first thing we need to do is to go on our Dublin router, because this is actually where we need to make our configuration. We simply use the command enable and enter, and next configure terminal and enter. And next we need to select the security package for our IPS configuration on our network. To do this, we need to type the command license boot module C1900 technology package security K9. So basically, this is our security package that we need to install on our router to actually be able to utilize the IPS configuration on the router. Type in enter and press yes to answer the question. So the system requires us to reboot the router due to the new security module installed. But before we reboot our machine, we need to copy the running configuration that we just downloaded and load that configuration into the startup configuration so that when we reboot our router will actually reboot with the new configuration we just downloaded. So on the terminal, simply use the exit command and type in the command copy running config startup config and enter. Now it is going to ask us what's the destination name, because we don't want to change the name that we normally call our running configuration. We simply press enter, and it basically builds the whole entire configuration with the new configuration. So now that is done, all we need to do is simply use the command reload and simply hit enter. And we reload our router with the new security module we have downloaded. Okay, so at the moment, the configuration of the security package we downloaded is done. And we can confirm that we have this configuration on our start configuration by using the command enable, enter, and show run, enter. And when we scroll through the configuration, you can see we now have the license module. And it is a Cisco 1941/K9 security package. So that was the module we downloaded earlier, and we have it running on our router. So now that we have that done, the next step will be to make a directory for our IPS configuration. So we simply use the command to make our directory by typing the command mkdir ipsdir. And we call the directory ipsdir and press enter. So now at the moment we have successfully created the directory, but the directory we have created is just an empty directory on the router. So we need to now specify on the router that we want to use this directory to host our configuration for our IPS. So to get that done, we simply need to type in the command configure terminal, enter. And next we type in the IPS config and our location, which is the directory we created earlier. So we just copy the name and paste it and enter. So now what we've done so far, we've created this directory IPSDIR. And in this directory, we have assigned this directory to hold all of the IPS configuration that we will be creating on this router. So now that we have that done, we simply need to name our IPS. So still on the terminal, we just put the command IPS, name, iOS, enter. So what we could do next, since we want to be able to read the log from our IPS, we enter the command IPS notify log and enter. So the next thing we would need to do would be to verify our date and time. And we need to set our date and time in the Coordinated Universal Time, UTC. Now, why is this important? Because in a real-life scenario, we would want to be able to identify what time every piece of traffic enters our network. So when we actually get a log entity, we can correlate the log with the time it actually came into the system. So on the router, we could go back to a global configuration mode. We have the hash sign, and we simply use the command clock. And we can set our clock to the Coordinated Universal Time, UTC format, which is hours, minutes, and seconds. So I simply just use 21:00:21. And next will be to specify the day, month, and year. And the day is the 3rd, month is March, and the year is 2021. And after that, you press enter. So now at the moment, we've successfully set our clock, and we can verify the previous modification we've made on the router by using the command show run. And when we scroll through the run configuration, we can see the directory we created earlier and other configurations we made on the router. So we scroll down by pressing more, and we can see the entire configuration that we've made so far. So now that we've done that, we can use the command copy running-config startup-config because we need to copy all our running configurations again, including our dates and our times, to also be saved so that whenever we restart our router, this configuration will still be here. Okay. And then we're just going to press enter. Next, we use the command reload, enter, to reboot the router. So now that we have that done, we have successfully set the time on the router, so we can configure the router to monitor all traffic that actually comes into the router. Now the next step would be to configure our service timestamp on the terminal. Since our machine just started up, we can use the command enable and simply use the command configure terminal. Okay, and next we can use the command service timestamps. And we can use a question mark to show other options with the service timestamps. And from the timestamp, we want to actually create a log. And in the log, we want the log to use a date and time format of milliseconds. So now we have created the time log on the router. We want to send the log entity to our syslog server. So basically, we want to send every log entity that we get on the 192.168.5.0 network and send that log entity to the syslog server we have at 192.168.5.4. So still on the terminal, we type in the command logging host 192.168.5.4. So now we have successfully sent our log to a host, which is our syslog server. Let's review our tasks for this demo again. First, we have successfully done the first task. Enable the IPS on the router to filter all traffic coming into this network. And next, we need to actually set the rules in our configuration for our IPS to drop every ICMP traffic sent to the network. So we simply click on the Dublin router, and all we need to do is use the command to actually set that rule on our configuration. So we type the command IPS. And next we type in signature-category. So now we have our signature categories. This is how you specify the rules to make modifications to our configuration. So now we will specify by using all categories. So we're specifying every category on this IPS. So the next thing we can do is we can retire this category to be true, meaning when the signature inspects traffic, a report of false positives will be ignored and only true positive will be reported. So we type retired true and enter. Exit for the previous command. And next we need to set another category on the terminal. Simply type in the command category iOS underscore IPS basic. And we would repeat the same step we did for the previous category. So we set the retired to true by using the command retired true and exit for that category. So now we have that done, we will be specifying a set of rules. Now we just connected to a specific interface on the router. So if we go back again to our network topology, the Dublin router is connected to the network on interface Gigabit Ethernet 0/0. So this is where we need to apply the IPS configuration. So on the terminal, we exit, and we get a prompt asking if we want to confirm. Simply just press enter to confirm, and it builds our IPS configuration signature with the new set of rules. And since that is done, we can just type in the command interface Gigabit Ethernet 0/0 and enter. And we will specify the configuration on this specific interface. So it can be activated by using the command IPS. And we specify the name of the IPS we have created, which is iOS IPS. And we specify outbound and simply press enter. So at the moment, you can actually see something happening instantaneously. Now, our engine has been built, and simply, it's actually started capturing the traffic on that specific interface. Now, let's confirm our running configuration on the router. We use the command exit and type do show run to show our running configuration we have on our router. When we scroll through, you can see we were able to set our timestamp. And we have only one entry. And our IP signature category is set for all. And retired is set at true. From the configuration, it shows that one step was missed, which was the definition of our IPS signature. And this is why it is important to always check configurations to avoid mistakes. So let's jump back to make the last configuration we missed. So, on the terminal, type the command IPS signature definition, enter. Now we need to specify the signature definition, which will be outputted from our log. And we will be using a signature of 2004 with a subsignature ID of 0. And we will set our signature definition to have a status. We will set the status to display all the false positives by using the command retired false and enter. And we use the command enable true to display the log. So now that we have that done, we simply exit. Next, we go into our security engine. And while we are in the engine, we can now create an events alert, which will display each log event each time any condition is met. So we can type the command event action produce alert and enter. So what is next? Do we want the alerts reflected? In this case, we want to deny ICMP echo requests from entering the router. So we type the command event-action deny-packet-inline. So now that we have that done, we can just exit and we get a confirmation. If we want to proceed with a configuration, simply press enter. At the moment, we've successfully configured our IPS, and we also defined our signature we actually created. And in the signature, we set the signature to have the status to be able to actually generate alerts and set those alerts to deny any packets in line. So what that means is we will be blocking every ICMP ping echo packet being sent to this network. And we can simply test this out to verify that our configuration actually works. So we go to our sales PC, which has an IP address of 192.168.1.5. And simply click on this. And on the sales PC, we can try to ping the other sales PC at 192.168.5.3 by using the command ping 192.168.5.3. And you can see we've sent our ping. And we will wait to see what response we get, and then we will go to a machine to verify that this ping was sent to our network. So you can see at the moment we've actually successfully blocked all the pings. And if I go to the router in Dublin, you can see we have generated a lot of traffic. And now we can see the last ping was from 192.168.1.5 to 192.168.5.3. And if we inspect this, we can see the sales PC with IP address 192.168.1.5. Actually trying to connect to one of the machines. And on the router, we can see the timestamp when this actually happened. So there's the timestamp, and we can see the signature. And we have the signature definition, which shows what type of traffic was prevented. In this case, ICMP with a signature of 2004 with a subsignature ID of 0. And we can actually see the risk rating, which is 25. So we see the benefit of actually creating the IPS on a network. So when the IP has been configured, any traffic that's coming into the network can be prevented. And with the IDS on the network as well, we can also detect the traffic once it enters the network. I hope this demo was informative.